السلام عليكم ورحمة الله وبركاته. Today we'll be speaking about the integrated rate law. The last time we have taken the rate law, but the rate law that we have taken last time is called the initial rate law or the initial method rate law. The last time it was called initial rate law because whenever we try to calculate the rate of the reaction, we depended on in the calculations on the initial rate of the reaction. That's why it was called the method of the initial rates or the instantaneous rate, which is happening directly after beginning the reaction. So the initial rates is when the t is just after 0. Time is just after 0. And although this way was easy and good to find the rate law of the reaction, but it had one problem, is that it doesn't count for the whole reaction. It only can show you the reaction rates depending on the beginning of the reaction. But it doesn't give you an idea about what happens later when the rate of the reaction increases or decreases. The second method for finding the rate of the reaction or the rate law is the integrated rate law. The integrated rate law. And this one is a little bit more complicated because it depends on integration, but it gives us an idea about what happens through the whole reaction. It will tell me what will happen to the rate of the reaction according to the changes in the concentrations, of the reactants through the whole reaction. And in order to do this, we will need to do differentiation using math, but we'll try to keep this as simple and away from math as much as we can. We'll just get some equations to use and then we'll just apply them. Let's first see a reaction in which I have only one reactant. So let's say this reaction is having one reactant, which is A, and it has a number of moles. And this reaction has changed into product. We have calculated the product for the last time by saying that the rate of the reaction is equal to the change, so delta, the concentration, change in the concentration of the reactants divided the change in the time. And because this is reactant, as we mentioned, it has to be always negative. So it has to be always negative so that it will give me the result in a positive value for the rate at the end. So negative, the change in the concentration over the change in time. And the other method, the other law is telling us the rate law is equal to, also rate is equal to what? So I can say rate is equal to what? Let's write it in a different line. K, and this is a constant of proportionality, multiplied by the concentration of A to the power of N. And we said that I don't know N by any method except experimentally. So in case if N is equal to 1, this means that the reaction is first order. And in case if it is N is equal to, then it is second order. If N is equal to 0, it is 0 order. Okay, let's remember together what is the effect of changing the concentration on the rate if it is first order, Yasin. If it is first order reaction, what will be the effect of changing the concentration? When you change the concentration in the first order, the rate of the reaction is going to be changed in the same way. So if you increase the concentration by 1 time, the rate will be also increased by 1 time. If the concentration is increased by multiplying it by 2, the rate of the reaction is going to be changed by multiplying it by 2. If you divide it by 3, it will be divided by 3, and so on. What about the concentration versus rate? Concentration versus rate. If it is the second order, ya Abdullah. Abdullah, if it is second order, what happens if you increase the concentration? The N is equal to 2. What happens to the rate of the reaction?
It will also be increased to 2.
It will be squared. It will be squared. I have increased it by 2. And what is the square of 2? أنا قلت الحاجة اللي هعملها whatever I do will be squared. يعني 2 to the power of 2. يعني لو الكونسنتريشن زاد 2 so it will be الريت هيزيد 2 to the power of 2. and what's 2 to the power of 2? 4.
4.
Okay, طب what if I increase the concentration by 3? The rate will be 3 to the power of 2. يعني multiplied by 9. طب what if I decrease the concentration by 4 divided by 4? So 4 to the power of 2 is what? 16. So the rate will be decreased by 16 times. Whatever I'm doing the square of it. The square of it. Okay. Right. Let's see. Right. What is the difference between this? This is still the old method. We said we'll speak about a different method. The different method that's called the integration. Let's take one table and see what are the results. I have brought a reaction, for example, in which the nitrogen pentoxide is reacted. So let's see how this will show. I have a reaction in which N2O5, which is nitrogen pentoxide, is decomposed and forms two different molecules, 4NO2 and O2. This is the different two ones, that's NO2 and O2, that will be formed. Okay, so I make by experiment and I found that the rate law is as follows. So it is KN2O5. So Yasin, if it is like that, what is the order of the reaction? Is it zero order or first order or second order?
First order.
Yeah, it's first order because it is to the power of 1. So if it is to the power of 1. Okay, I found this is by دايما قلت ان انا experimentally, I found it only experimentally. This means that the concentration of N2O5 is doubled, then the rate of the reaction will be also doubled, and the rate of production of NO2 and O2 will be also doubled. Okay, I can write this by the new method that we'll talk about today, which is the integration by, now we'll speak about the integrated rate law in a different method. We will write it like that, and I need you to memorize it only. I will say that the ln of the concentration of N2O5 is equal to negative K multiplied by T plus ln the concentration of N2O5 at 0. Don't be afraid from this one. We'll just memorize it and use it. So let's say it again. I will find the rate law by the integrated method by writing this equation in which it is used integration. The ln is the natural logarithm. This is the natural log. And what's T? T is the time. This is the benefit of this law. Now I can use this to find the rate law at any point. Now the difference is the last time I only made it using the initial rate, which means the time is directly after zero. أنا لسه بادئ experiment. I just started the experiment. What is the concentrations now? What is the rate now? But what if I want to make it at any time of this reaction, after 5 minutes, after 6 minutes, after 2 seconds? Then you can just use this equation where the t is the time and ln is the natural log of the concentration at this time. So natural logarithm of, or natural log of N2O5 concentration at time t. Now what about N2O5 0? It means at which time? At time 0. So here I don't have the concentration of N2O5, ya Abdullah, one time. I have it 2 times. The first time is at time 0, and the second time, the first time is at time t. I'm sorry, I wrote time 0. It should be at time t, at a certain time, whatever time I'm asking for. And here at the time 0 at the beginning of the reaction. This is called the integrated rate law. So if I remove this one and I put it general for any equation, not only for N2O5, for any equation, I can just write it as follows. I can just write it like that. Ln, the concentration of the reactant that you are speaking about at certain time, is equal to negative the constant of proportionality multiplied by the time multiplied by ln the concentration of A at time is equal to 0. So this means that the concentration will depend on the time. So the concentration will depend on which time you are talking about. So if you have, for example, I have the initial concentration, which is called A0, and I have also the rate constant, which is K. I can find the concentration. I can find the concentration at any time. I can find, if you have 2 of these, I have the initial concentration when you started and the rate constant, I can find at any time, which is called T. What if I put this in a graph? What if I put this in a graph? I want to see how it will look like inside a graph. Why? Because we can recognize the order. This is the good thing about the integrated rate law. If you give me the graph, if you draw just the graph of the experiment, I can tell you if it is 0 order or first order or second order just by looking at the graph. If you made the graph and you put y-axis and x-axis, and then you draw the slope of the line, so you made the graph, and you put the natural log of the concentration, so you will put the natural log of the concentration like that, of the concentration at this time, versus time. So I did not put the time versus concentration, I put the time versus the length of the concentration, and you get a straight line. If you get a straight line, then you will know this is a first order automatically. Then you will know that this is a first order automatically without having to do anything in the experiment. And then we'll see the graphs now all together. We'll put them all together. So if you see a reaction and you make the reaction by experiment, and then you see that the graph of ln, the constant natural log of A versus the time is a straight line, you can automatically know that this is for a first order reaction. So I can write the equation in a different way. If you want to put this on the other side and put this one on this side, you can just write like that. You can say that the KT, I put the negative on the other side so it becomes positive, the constant multiplied by time is equal to the ln of A, the concentration of A initially, divided by the concentration of A at a certain time. You can just write the equation. This equation is only for the first order. Take care. This is only for the first order reaction. So let's have an example. The same equation that we have used, which is N2O5 broken down into 4NO2 plus O2. I have got some values for N2O5 concentration. So he gave me 0.1000, 0.0707, and 0.0125 and 0.00625. Give me some values for the concentration at different times by second. So this was at 0. Then the concentration of the reactant starts to drop. After 50 seconds, it becomes like that. After 6 minutes, it becomes like that. After 400 seconds, it be like that. So when I make the calculations, I found that the value of the rate is equal to change in the concentration divided by change in time. And I found that it is first order. How did you find its first order? Mister, I see that every time I'm changing the concentration, the rate of the reaction will follow with a certain way. Then I'll find it in the first order. The difference now is that, again, by just drawing the graph of two things, the time versus the ln, not the concentration, the ln. So if you put the time versus the ln of the concentration, the natural log of the concentration of N2O5. So every time you will take the table, every time you will put the table, then calculate the third thing. Or you have only N2O5 and time. Also calculate the ln of the concentration. بس natural log of the concentration. So اكتب هنا ln بتاع الكونسنتريشن ده. احسبه واحسب برضو the ln. Also calculate this one, and this one. Then make the graph between the ln, only the ln, and the time. You will see that this is a straight line, so it will come like that. Once I see it's straight line, I said that once I see that it's straight line, I will know that this is a first order reaction. So by just making the plot of N2O5, the length of it, versus time, and I see it is straight line, so I will just know that it is a first order reaction. Whenever I also try to apply my equation, I will say that the length of N2O5, and then I find as any concentration and any time, I will see that it follows the equation. So it will be equal to negative the KT plus ln N2O5 at time 0. And then I can find K if the K is required. Now I can find from the graph something also very useful, which is the slope. What is the slope? I will just find the change in Y. Like I will choose 2 points. I will choose this point and this point. And I will put them here. So now I can see the change in Y. What is the change in Y? I'll calculate this point minus this point. So the change in Y, and divided by the change in X, this point and this point. This means that you have checked the change in the concentration, the line of the concentration of the change of time. And when you find the slope, you will find that it's equal to negative K directly. So you can get the value of K from the graph also directly. So let's write it down. In the first order reactions بس في first order reactions your slope from the graph is going to be equal to change in y divided by the change of x اللي احنا قلنا عليها التشينج بتاعت ln of the concentration of whatever substance اللي هي عندنا كانت N2O5 at a certain time divided change in time. And then I can find the value of my k. يعني مثلا بالcalculations in this. So for example, in the calculations here, I found that the slope is equal to negative 6.93 multiplied 10 to the power of negative 3 second minus 1. And you said that the k is equal to the negative of the slope. So this will change it from the negative, Ya Abdullah, into the positive. So it will be equal 6.93. So you need to make negative of the slope. Slope is negative, so the k will be in positive value. S minus 1. الكلام ده تاني شكله ممل شوية. It's very boring, but it can help me in the real experiments to find the k value, the constant value. والconstant مهم جدا لأن أنا I can use it to find the concentration of the experiment في أي وقت من غير ما أضطر إن أنا أعمل repetition للإكسبيرمنت مرة تانية. Okay, how will the question comes like? He will give me مثلا الداتا, so he will give me the table and then tell me calculate, find the concentration of N2O5 after time 150 seconds. After 150 seconds has passed after the start of the experiment, the start of the reaction. You said that ln N2O5 at a certain time equal to negative KT plus ln N2O5 at time 0. So at time 150 seconds, you need to find this concentration, ln N2O5 at time equal to 150 is equal to negative K. We just found the K from the previous one, and we said it was equal to negative 6.93 multiplied 10 to the power of negative 3. So we'll keep it here, negative 6.93 10 to the power of negative 3 multiplied by time. Where is the time? 150. And add this to the ln of the concentration at 0. Mr. The concentration at 0, what did you say the concentration at 0 was from that table? At 0, it was 0.100. So at time 0, it was 0.1. So ln 0.1. Again, it's equal to negative K, which we found it out from the graph or from the slope, plus ln the concentration at time 0, and at time 0 the concentration was only 0.1. So I will just get the value, that's negative 1.040 minus 2.303. That's equal to negative 3.343. And this is Mr. the ln. So if you want to find the N2O5, the N2O5 at time is equal to 150. You will just get the anti-log. You will just get the anti-log of this value. 43. That's equal to 0.0353 mole per liter. This is the concentration after the time has passed. Okay. Now we'll talk about something called the half-life, and this is actually the most important practical application for the integration law or the integrated law. And sometimes there is an experiment or there is a medicine that I have taken and I have swallowed some of the tablets. So I have some headache and I have taken some paracetamol tablets. So paracetamol tablets or Panadol because I have some headache or I have some fever. And then this paracetamol goes to my blood. I have taken one tablet, which is 500 milligram, and this one goes to my blood, and it works very fast, the same way they are saying in the advertisement. Says that it works very fast. So the 500 milligram goes to my blood and then goes to the receptors and start working to relieve my pain and headache and fever. Then after some time, this 500 milligram concentration is going to decrease. Why it will decrease? Because some of it will go to the receptors, some will be excreted by the body, some will be removed. So I need to know how much time it will take for this 500 milligram to become zero. This is very important because before it comes zero, I have to take another dose. Because if I waited until it is zero, my fever will come up again. So I need to know what is the time exactly that 500 will change into zero. So before it becomes zero, or if I'm taking antibiotic, for example, I have to know, do I have to wait 12 hours or I have to wait 8 hours before I take my next dose? Which time it will become zero exactly? That's why I need to see something which is called half-life. This is a very important concept in chemistry. And as we said, it has many applications here. So I will need to know what is the half-life of my reaction, and specifically I will study it in the first order reactions. The half-life of a first order reaction is how much time is needed, so time needed or required for the reactant to reach half its original concentration, to reach half its original concentration. So if you started with 500 milligram Yasin, how much time it will take you to reach the 250 milligrams? And then how much time it will take to reach 125 milligrams? And how much time it will take to reach 62.5 milligrams? So if you noticed, every time I'm changing, I'm halving the dose. Every time I'm changing it, I'm halving the dose. The time that passed from this point to this point is called T half, or the half-life. We call it the T half. And then again, another T half. So it becomes halved. So again, T half. What is the T half? It's time. So it is either seconds or minutes or hours. So every time the concentration is halved, a T half has passed, or one half-life has passed. The symbol for it again is T half. Another application which is very important also, more than the medicines, for this T half application of T half, or the half-life of a substance, is the decomposition of the radioactive substance. Radioactive substance. For example, I have went to a place where there is a nuclear reaction or a nuclear disaster has happened, and I need to know radiation, for example, is coming out due to the presence of a nuclear substance. I need to know when this radiation is going to finish, when this place will be safe again. So I need to know how many T halves or how many half-lives this substance will take until the radiation stops coming out of it. Because this substance decomposes or breaks down. If you remember when you took in grade 10, when this substance decomposes, it breaks into two different substances. So for example, I have plutonium, which is broken down into uranium and something else and some neutrons. Then the uranium is broken down into another radioactive substance. So every time its mass decreases. So I need to know when it will become zero, because when it will become zero, there will become no radiation and this place will be safe. I need to know how much time it takes for this radioactive substance to be decomposed completely. Or let's use just our substance, which is the N2O5 that we have used a few minutes ago in our example. The concentration of N2O5 in molar at time 0 was 0.100. Okay, what happened after 100 seconds? The concentration, what happened to the concentration, ya Abdullah? It is halved. So we change it from 0.1 into 0.05. Then Yasin, one more 100 seconds. What happened to it? It's halved again. Change it into 0.0250. Then it's halved for one more time. It is 0.0125. So every time the 100 seconds passes, أنا عديت هنا قد إيه وقت؟ 100 seconds, and then 100 seconds, and then 100 seconds. So what is the change in time here? What is the change in time? 100 seconds. So delta T is equal to 100 seconds. And then delta T is equal to 100 seconds. 100 seconds passed. Delta T is equal to 100 seconds. So what happened to the concentration? Mister, you told me that you have 0.05. This is the final. Divided by 0. مش احنا بنحسب كده. That's how we calculate the rate. Change in concentration divided by change in time. Concentration 0.05 divided by 0.100 يعني ايه 0.100 يعني انت قليت النص. انت قليت النص ومن 0 سوري 0.05 على 0.100 يعني انت قليت النص وبعدين 0.025 على 0.05 يعني انت تاني قليت النص. So every time you are decreasing by the half. وبتاخد وقت قد ايه كل مره؟ How much time you take every time ياسين؟
half.
What is the time that's required?
100.
100 seconds. So what is the half-life of this reaction? Half-life is equal to 100 seconds for the concentration to be halved. Right, what was our equation before? Our equation was telling me that the A changes into products, and this is the number of moles, and again KT equal to ln the concentration of A at time 0 divided by the concentration of A at time T. ده اللي احنا اتفقنا عليه الاثنين rules. طب لما تكون التي بتساوي هاف، لما تكون التايم بتساوي هاف الانيشال تايم، لما التايم اللي عدى يكون هاف التايم اللي عدى، يبقى الكونسنتريشن بتاعتي A هتساوي تايم بيساوي هاف، هتساوي A concentration at the beginning والكونسنتريشن دلوقتي بتساوي 2. من غير ما تغلب نفسك كتير I will just give you one equation. مش عايزك تعرف هي جت ازاي but if you want to know it's like that. ln الكونسنتريشن بتاعت A عند تايم 0 A0 على 2 بتساوي K على T half. انا مش عايزك تعرف الكلام ده كله. I need you to know the final equation بس. عايز تحسب ال T half if you want to know how much time it will take the half life بس في الفيرست اوردر reactions بس اللي هو T half equal to 0.693 على ال K. I don't want you to know how this comes بس احفظ الايكويشن بس. ال T half بتساوي 0.693 the same number every time اللي جاها من 2 طبعا divided by A. الايكويشن دي جنرال ايكويشن بتطبق دايما على التي هاف في الفيرست اوردر. وخد بالك من النوت دي، very very important note. whenever he mentions decomposition أو mentions radioactive substances in the exam, this means that it is first order. خد بالك يا عبد الله, he is not going to tell you that it is first order reaction. هيقول لك كده مباشرة decomposition أو radioactive substance concentration decrease, you will know by yourself that it is first order because he is not going to tell you. مش هيقول لك دي first ولا second ولا third. الله يا مستر رومان, انا هعرف منين هي first ولا زيرو ولا second؟ انا هعرف لما هو يقول لي this is decomposition او radioactive substance concentration decreasing, so I will apply the T half of this one. خد بالك, this is for the first order only because after a while I'll give you the half life for the second order and I will give you the half life of the zero order. بس انت مش هتستخدم غير ديت لو قال لك decomposition او radioactive. يعني الابلكيشن بتاعها is very easy. So how to apply it is very easy. This is a problem. I have a reaction which is first order and this reaction half-life طلعت بتساوي 20 minutes. يبقى انت محتاج 20 minutes يا عبد الله عشان الكونسنتريشن بتاعتك تنزل للهاف. طيب calculate K of this reaction. هي ايه الايكويشن يا مستر اللي انت قلت لي استعملها؟ احنا قلنا 1 equation T half بتساوي 0.693 على K. So what is K? 0.693 over T half. يعني 0.693 و T half بتساوي كام؟ 20 minutes. 0.693 على 20 is equal to 3.47 to 10 to the power of negative 2 minute minus 1. That's it. تاني حاجة بيسألني بيقول لي how much for reaction to be 75% complete. For reaction to be 75% complete. يعني ايه 75% complete يا عبد الله؟ يعني 75%. 75% of the substance finished. اتحولت خلاص من reactant إلى product. يبقى ادي reactant. This is my reactant. This part is finished and this part is finished. Change the product خلاص و this part is finished. ومش باقي في الرياكتنت غير قد ايه يا عبد الله؟ 25% بس اللي باقي. امال ال 75% اللي حصل لهم كلهم اتحولوا من رياكتنت الى برودكت.
برودكت.
هو بيسالني هياخد وقت قد ايه؟ هياخد وقت قد ايه؟ مستر انت بتقول ان دوت فيرست اوردر. مظبوط فيرست اوردر. وانت قايل لي اللين الايكويشن بتاعت الفيرست اوردر ايه؟ اللين ناتشورال لوج بتاع الاي كونسنتريشن بتاعت ايه عند الزيرو والكونسنتريشن بتاعت الايه عند التايم ده بتساوي كي في التي. خد بالك احنا لسه جايبين الكي منين؟ تي هاف بتساوي 0.69 على 3 على الكي. لسه جايبين الكي من هنا. خلاص just put the calculations together. Just put the numbers together. مستر لين الكونسنتريشن عند التايم انت بتقول 75% كومبليت، يعني الكونسنتريشن دلوقتي بقى كام عند التايم تي؟ بقى 25% صح؟ مش الرياكتنت خلص منه 75% اتحول للبرودكت، يبقى باقي فيه قد ايه دلوقتي الكونسنتريشن؟ 25%. خلاص اقول لك اهو الكونسنتريشن بتاعت A على الكونسنتريشن بتاعت ال A عند ال N multiplied by 100 بتساوي 25%. تاني I will write it for you. You said len, this is first order. Len of concentration of A at time 0 over concentration of A at time T اللي أنا مش عارفه قد إيه وقت قد إيه عدى بيساوي K multiplied by time T. أنا مش عارف وقت قد إيه عدى. Oh my God. Sorry. يعني يا مستر الكونسنتريشن بتاعت ال A كام؟ 75% خلصت، باقي 25%. والكونسنتريشن بتاعت ال A عند التايم اللي انا التوتال كله N كام؟ 100. التوتال كله 100 multiplied by 100% هتديني 25%. يعني ال A دي عند ال A بعد ما عدى ال N. يعني ايه N؟ What is the meaning of N؟ يعني how many half lives عدت؟ يعني نقصت النص كام مرة؟ أنا عايز أعرف إيه يا عبد الله؟ عايز أعرف هي نقصت النص كام مرة؟ عدى عليها النص كام مرة؟ لأن النص ديت هي اللي هتعرفني نقصت النص نقصت النص. So N is how many half lives عدى عليها. How many half lives has passed. يبقى A على ال A N بتساوي 0.25. او اقول ان الاي عند الكونسنتريشن عند التايم 0 على الكونسنتريشن بتاعت الاي بتساوي 1 اوفر 0.25 يعني 4. يعني انت يا مستر عدى عليك كام هاف لايف؟ 4 هاف لايفز. Let me write the answer. يبقى اللين بتاع الكونسنتريشن A at time 0 divided concentration A بتساوي لين ال 4 بتساوي K في T. وانت قلت لي الكي من السؤال اللي فات 3.47 في 10 to the power of negative 2 multiplied by t. يعني خلينا نحطها جنب بعض. So you can simply say that t بتساوي ln the 4 divided by 3.47 multiplied 10 to the power of negative 2 هيطلع عندي 40 minutes. السبستانس بتاعتي علشان توصل من الكونسنتريشن 100% وتنزل تبقى 25% بس 75% منها تحول لبرودكت خلاص خدت 40 minutes. الطريقة ديت بالماث بتبقى كويسة، لكن أنا ممكن أعمل طريقة تانية بالإيماجينيشن شوية. إزاي؟ Let's say my substance الكونسنتريشن بتاعتها كانت في البداية مثلا 1 مولر. بعد 1 هاف لايف هتبقى كام يا عبد الله؟ نقصت النص. 1 تي هاف عدى عليها هتبقى
0.5.
0.5 وعدى عليها هاف لايف كمان بقت كام؟
0.25.
25. انا ال 0.25 على ال 1 كام؟ 25% صح؟ 0.25 اللي اتبقت دلوقتي بعد ما عدى 2 هاف لايفز صح؟ 0.25 على الانيشيال اللي هي ال 1 بتساوي قد ايه؟ في ال 100 25%. وانت قلت عدى عليك قد ايه؟ 25%. يعني عدى عليك كام هاف لايف يا ياسين؟ 2 هاف لايفز صح؟ عدى عليك 2 هاف لايفز. واحنا قلنا الهاف لايف الواحده كانت بكام لما حسبناها؟ لما قلناها في الاول من اول من السنه. الهاف لايف الواحده كانت بكام يا ياسين؟ 20 minutes، وانت عدى عليك 2 هاف لايفز، يعني عدى عليك 20 بلس 20 يعني 40 minutes. So 20 plus 20 يعني عندك عليك 40 minutes. طبعا دي سهلة علشان الأرقام واضحة قدامي، لكن لو الأرقام معقدة 3.75 وأرقام صعبة I cannot get it by thinking like that، ولازم أستخدم الإيكويشن ليها. طيب كل اللي احنا قلناه ده كان على الزيرو اوردر رياكشن، على الفيرست اوردر رياكشن. هناخد السكند والزيرو بعد شورت بريك لمدة 3 دقايق أو 5 دقايق بس. Okay, Bismillah. The only thing that I'm gonna do different in the second order and zero order reactions is that second order integrated law. We are always talking about the integrated law. Is that the equations will be different. So if the A reactant change it into products, the rate at this time in the initial rate law from the last time equal to a negative change of the concentration of A over change in time, or K a to the power of 2 because everything that I do in the concentration is doubled or is squared. I'm sorry, not double, squared. So the integrated law actually is looking different from the one for the first order, because this time I will say that 1 over the concentration at any time is equal to K multiplied by T, not negative. Take care, the last time it was negative K and it was with the ln. And I will say plus 1 over A N. But I'm saying again, the most difficult things in this part is just memorizing the rule. But once you memorize the rule, you will be able to automatically answer the questions. So we will be automatically able to answer the questions. So let's say I make an equation and I made this time a relationship like the last time. If I try to find the graph between ln of the concentration this time and the time, it will not make the same curve. It will not make the same curve because it's not first order. Only the first order is going to make the graph that we have shown. بس الفيرست اوردر هو اللي هيعمل لي الكيرف اللي انا اتكلمت عليه اللي هو ستريت لاين ما بين اللين كونسنتريشن والتايم. ده بس فين؟ في الفيرست اوردر only in the first order. In second order and zero order, it will not make the same curve. It will make curve only if I make the curve between this time. I will not make it between ln A and time. In this case, I will make it the graph between 1 over A versus time. 1 over A versus time. And it will make a straight line, and I'll show you the graph also now. So the concentration of A at any time is equal to the concentration of A initially divided by 2. This is the half-life. The half-life in the second order. The concentration after the half-life, the concentration after the half-life passed is equal to the concentration initially divided by 2. The same definition for the half-life. But what is the equation that I use? The T half of the second order reactions is equal to 1 over K multiplied by the initial concentration. So let's find an example so that we can apply this one. So the last time we said that for the first order reaction, this is the only thing that you need to memorize. T half is equal to what? في حد حفظ؟ It's equal to في حد لحق يحفظها؟ 0.693 over K. This time for the second order T half is equal to 1 over K multiplied by the initial concentration. بعد ما هتحفظ الايكويشن دي اغبى شيء فيه في الموضوع خلاص you will just apply the values. You will just apply the values and then it will be just direct application. طيب خلينا نشوف example ونشوف الاكزامبل ازاي هنعمل application للكلام دوت. I have a substance which is called C4H6. 6 C4H6 is a butadiene, which means that it has 1, 2, 3, 4 carbon atoms, and these 4 carbon atoms has 2 double bonds, so it's called a diene. Its formula is C4H6. It's a gas. When 2 molecules of the butadiene, of course the hydrogen atoms are there. When 2 molecules of this one join together, they will join to form one compound called CH12. So one of these plus another one forms a gas of C8H12. So I check the concentration of this one by molar at time equal to 0 in seconds when I did not start anything, 0.01, and time is equal to 1000 seconds, it's 0.006, and time 1800, 0.004, and so on. I can see that as I go down, or I go with the time, the concentration, of course, of the reactant drops. It's actually but what happens for the rate of the reaction? Is this a first order or is it a second order? So I said that if I cannot do it experimentally, الحاجة اللي أنا استفدتها من الانتجريشن لو إن أنا بقدر أعرف بالكيرف. Last time you told me, Mr. if the curve is what shape, if it is ما بين اللين بتاع الكونسنتريشن versus time and it is straight line like that, it is what order? It's first order. لو طلع الكيرف بدل ما يطلع عنده straight line، بدل ما يطلع straight line زي كده، طلع الكيرف not straight line, it's just doing like that, then it's going to be a second order. يبقى الشكل بتاع الكيرف يا مستر عرفني من غير ما اقعد اعمل اكسبيرمنت ولا حاجه، من غير ما اقعد احسب اي حسابات، لين للاي طلع كده then it is second order not first order. امال امتى بيطلع straight line؟ I will show you when to make the straight line. So هطلع المره دي بدل زي ما قلنا، بدل ما نقول اللين بتاع الكونسنتريشن، what did we agree about Mr. It will be 1 over K multiplied by the concentration. 1 over K, sorry, 1 over الكونسنتريشن نفسه. هعمل كيرف ما بين ال1 بتاع over الكونسنتريشن، يعني reciprocal of the concentration versus the time. So instead of making the curve between the length of the concentration, natural log of the concentration, and the time, I will make it now for the second order, the time versus the reciprocal of the concentration. So I'll divide the concentration at time t, 1 over the concentration by time t. In this case, it's going to make a straight line this time. It's going to make a straight line, but not with the length. So I'll just take the values and put them on the graph. I'll just take the values and put them on the graph and make the graph. مستر خد بالك من حاجة خطيرة جدا جدا. This time the graph is not going to look like that. ازاي يا مستر؟ مش ده الكونسنتريشن، مش ده الكونسنتريشن يا سيدي. Isn't this the concentration؟ تمام. الكونسنتريشن بتاع ايه؟ reactant ولا product يا مستر؟ reactant. والكونسنتريشن بتاع الرياكتنت ده over time ايه اللي بيحصل له؟ بيقل. بس خد بالك يا عبد الله، this is not the concentration of the reactant, this is 1 over the concentration. يعني لو كان الكونسنتريشن 10 وبعدين بقى 5 وبعدين بقى 2 ما هو بيقل، لكن لو قلت 1 over 10 1 over 5 1 over 2 what happens to the number? This is 0.2 sorry 0.1 وده 0.2 وده 0.5. so the concentration يا ياسين، the concentration decreases، لكن الريسيبروكال بتاع الكونسنتريشن بيحصل له ايه؟ بيزيد. take care, I didn't say concentration, I said 1 over the concentration. So instead of the curve increasing by time, it will decreasing by time, it will increase by time. So the curve will increase by time. يبقى لو لقيت الكيرف بتاعك لل1 over reciprocal بيعمل straight line و increase by time, this will be a what type? This will be a second order. This will be a second order reaction. امال لو حاولت اعمل الريسبروكال، سوري، لو حاولت اعمل اللين، زي ما قلنا، زي ما عملت في الفيرست اوردر، لا مش هيطلع لي straight line. The line will look like that. If you try to make the line of the concentration at time t versus time, it will not be a straight line. طيب لو عملت السلوب يا مستر، انا عايز احسب الكي، انا كمان انا عايز احسب الكي تاني بتاعت السكند اوردر من الكيرف على طول اوتوماتيكلي. So if you want to find the k is the slope. برضو الكيرف اهو، this is 1 over concentration at time t and this is time. خد التشينج في الواي، take the change in the y كانت كام وبقت كام، وخد التشينج في التايم كانت كام وبقت كام. So slope equal to change in y will change of x. What is the y يا مستر؟ The change in y is change in 1 over the concentration، مش concentration. change in 1 over the concentration على ال change in time. الكي بتساوي السلوب بتاعتي. خد بالك المرة اللي فاتت السلوب كانت بتساوي ايه؟ You remember what was the في الفيرست اوردر؟ What was the slope like last time؟ negative k. خد بالك السلوب المرة اللي فاتت في الفيرست اوردر كانت negative k. لكن what is the slope this time? The slope is k directly. So if you want to find the k, just make the curve between the 1 over the concentration and a certain time and the time and take the slope of it. It will get you the value of the k directly. والتي هاف اتفقنا ان التي هاف بتساوي ال 1 over k multiplied by ال A initial concentration. قبل ما نقول الزيرو اوردر بس هنبين حاجة مهمة. قبل ما نقول الزيرو اوردر رياكشن ونعمل الكومباريزون ما بينهم كلهم، هنقول حاجة مهمة. في الفيرست اوردر التي هاف كانت بتعتمد على الايه؟ على الكي بس. So depends on K only. صح؟ مش كده؟ سألين التي هاف كانت بتساوي ايه؟ ال 0.693 divided الكي. يعني التي هاف كانت بتعتمد على مين؟ على الكي بس، ما كانش ليها اي علاقة بالانيشال كونسنتريشن، لكن التي هاف هنا بتعتمد على الكي مالتيبلايد باي انيشال كونسنتريشن. يعني ايه؟ يعني الوقت اللي السبستانس بتاعتك هتاخده علشان تخلص، وتنزل التي هاف تخلص، هيعتمد انت عندك قد ايه في الاول. والله لو عندي انيشيالي الكونسنتريشن هاي، التي هاف بتاعي بيقل. لكن كل ما السبستانس بتاعتي بتبدا التي هاف كل مره انها تزيد، التي هاف بتقل. So there is inversely proportional ما بين relation between the T half and the K. خد بالك this is important. التي هاف في الفيرست اوردر بتعتمد على الكي بس. التي هاف in the second order depend on K and the initial concentration both of them. So let's write it in this slide. Depends on K. لكن في السكند اوردر T half depends on your constant and الانيشال concentration انت كنت بادي كام. طيب let's see the zero order reactions. واحنا قلنا قبل كده ان الزيرو اوردر رياكشن اللي ما بتعتمدش خالص على التشينج بتاع الكونسنتريشن. الزيرو اوردر reaction does not depend at all. يعني الريت is equal to KA multiplied by 0. واحنا قلنا ال A to the power of anything سوري احنا قلنا اي حاجه to the power of 0 is equal to 1. يعني الريت بيعتمد على الكي بس، ما بيعتمدش على الكونسنتريشن. whatever you do as a change to the concentration will not make any effect on the rate of the reaction. This is for the zero order reactions. طب what does the integrated rate law بيقول لي؟ It's telling me that the concentration at time t equal to negative kT plus the initial concentration. So if you make the graph this time between the time zero order and the change in the concentration عادي خالص. خد بالك أول مرة كان في الفيرست اوردر اللن، تاني مرة كان الريسيبروكال بتاع الكونسنتريشن، المرة دي أول مرة اتكلم على الكونسنتريشن نفسه زي ما هو دايركت. It will make a straight line directly. بيقل ولا بيزيد؟ طالما انا ما قلتش reciprocal يبقى الكونسنتريشن as long as I did not say reciprocal the concentration decreases of course with time. The last time only in the second order I said the concentration is increasing with time because I was not actually talking about the concentration, I was talking about the reciprocal of the concentration. طيب when I made the graph in the zero order between the concentration change and time I found it is the straight line. What is the T half in the zero order? The T half in zero order is equal to the initial concentration divided by 2K. المرة اللي فاتت كنا بنقول it does not depend on the initial concentration, only on the K في T half بتساوي K في first order. Then we said in the second order it depends on the K and the initial concentration. In the zero order, T half is equal to what? The initial concentration divided by 2K. So also depend on K and initial concentration. زيها زي السكند اوردر. الوحيد اللي ملوش دعوه بالinitial concentration هو الفيرست اوردر. علشان كده دايما لما بتكلم على الديكومبوزيشن خد بالك take care whenever I talk about decomposition or substances that are which are radioactive I will say it is what? It is first order. ما بيفرقش معايا السبستانس ديت انا حاطط منها كتير I don't care I put high concentration ولا low concentration. It depends on the K of this substance. السبستانس دي بتقعد قد ايه؟ مستر الدواء دوت بعد ساعة 6 ساعات بيبتدي يختفي خالص. This plutonium it will stay 1 million year عشان تخلص الكونسنتريشن بتاعها يحصل لها radiation slowly. So decomposition or radioactive substance أول ما تشوف الكلمة ديت تعرف automatically he will not tell you. معظم الأسئلة he will not tell you. He will know that I'm speaking about first order and I will apply all the rules from the first order. دايما الزيرو اوردر بيبان معايا امتى؟ طب احنا قلنا راديو اكتيف الفيرست اوردر، امتى هلاقي عندي الزيرو اوردر؟ ذا زيرو اوردر دايما بيكون عندي سبستانس، مثلا عندي اي ميتال or catalyst is needed for the reaction to happen, is required for reaction to happen. وده بيحصل غالبا مع الزيرو اوردر. Okay. Now we have taken all the orders and the integrated law of all of them. We can just compare them now. Let's say Bismillah. زي ما قلنا once you know the rules all of them you can just simply applied، ولكن أغبى شيء بس الجزء الأولاني بتاع الحفظ فيها بس وخلاص. So let's put it all together. بسم الله. Just write it like that. Integrated rate close with the zero order or first order. So we said rate equal to change in the concentration of negative change in concentration of A divided by change in time equal to K multiplied by initial concentration to the power of 1 . So I will say ln of the concentration of A at time T equal to negative K multiplied by this time added to the ln of the concentration at time 0. If I made a curve between or a graph between the ln of A, time, versus the ln of the concentration at time T, then I will get a straight line like that. The K unit will be always, didn't mention them. The unit of K will be always equal to time minus 1 let's put this up. T half is equal to ln 2 over K أو 0.693 over K. وأهم حاجة في الموضوع كلها إن all radioactive decays are first order reaction. all أهم شيء الناس بتبقى عارفة كل حاجة في الآخر ما تاخدش بالها إن ديت first order. all radioactive decays are first order. Where to keep it? Let's keep it here. طيب, if I looked at the second order, I will say that the rate is equal to, again, the same thing. I will just copy the same thing, change in concentration of A divided by change in T equal to K A to the power of 2 this time. So I'll just say that 1 over the concentration of A at time t is equal to k multiplied by the t plus 1 over the initial concentration. And in this time, if I made the plot in the form of concentration, it will not make a straight line. The only way that I can make a straight line out of that, 2 times, is that when I make the reciprocal, of the concentration at time t versus time, and this is going to get me a straight line. And don't forget please in the multiple choice، خاصة المالتيبل choice، ناس كتيرة جدا في المالتيبل choice they will choose the one that's like that. خد بالك هيجي لك في الامتحان ياسين يقول لك is this the curve ولا is this the curve for the second order، اقول له لا، this is 1 over the concentration not the concentration. So by time the 1 over the concentration increases not decreases. And the slope طبعا هي بتساوي، احنا كنا بنشرح السلوب don't forget the slope. How to find k؟ السلوب بيساوي ايه؟ negative k، وهنا السلوب بتساوي k direct. If you want to find the k you just find the slope اللي هو ال change in y divided by change in t. What is the unit? The unit for the second order is mole minus 1 time minus 1. مولر minus 1 طبعا مش مول، مولر minus 1 اللي هي مول بير ديسيمتر كيوب divided by time اللي هي time minus 1. اوكي تي هاف بتساوي 1 over k multiplied by the initial concentration. اوكي الهاف لايف هنا خد بالك الهاف لايف is not constant. خد بالك يا عبد الله الهاف لايف بتاع السبستانس هنا في الفيرست اوردر ثابت. يعني ايه؟ يعني السبستانس كانت 500 صح؟ بعد الهاف لايف الاولاني 10 ساعات بقت كام؟ 250، وبعدين 10 ساعات تاني بقت 125. هنا بقى التي هاف مش ثابت. ليه؟ التي هاف بيعتمد هنا على ايه بس يا ياسين؟ على الكي. لكن هنا الكونسنتريشن نفسها اتغيرت. يعني ازاي؟ التي هاف بقى 250 10 ساعات، تيجي تبص بعديها الهاف لايف اخد قد ايه؟ تلاقيه اخد 12 ساعه عشان ينزل النص. مستر انت قلت كل ما هتزود كل ما هتقلل الانيشال كونسنتريشن كل ما الهاف لايف هيزيد. طب ياخد وقت قد ايه عشان ينزل النص تاني؟ 14 ساعه. يبقى الهاف لايف از نوت وات يا ياسين؟ is not constant. ليه؟ لانه اعتمد على مين يا ياسين؟ على الانيشال كونسنتريشن، والانيشال كونسنتريشن اللي حصل لها اتغيرت. لكن هنا الهاف لايف is what يا عبد الله؟ it is fixed. The last one is the zero order. The last one is the zero order. I will say now that the concentration initially at time t is equal to negative the k multiplied by t plus the initial concentration. برضو الهاف لايف not constant. برضو الهاف لايف not constant. خد بالك many times this question comes if you are asked why because it depends on the initial concentration. وكل مرة بقسم فيها concentration every time I'm dividing the concentration the initial concentration changes. What is it equal to? T half equal to the initial concentration divided by 2k. The plot is this time also decreasing in the concentration, not increasing. And it's directly between the initial concentration and the time. You will find a straight line. So you can just know the order from just having a look at your graphs. Let's have a question or two. You just have 2 or 3 practice examples on that. Okay, this is a question. The decomposition of a chemical B is first order with rate constant of 2 multiplied 10 to the power of -1 اللي هي ايه rate constant اللي هي الكي. So he didn't tell me anything about the order, بس انا اول ما شفت كلمة decomposition I know what ياسين that this is the first order خالص. So I will just assume it is first order. Determine the half-life of B. خلاص. The T half is equal to ln 2 اللي هي 0.693 divided the K, and I'm giving the K 2 multiplied 10 to the power of -1. So just divide this one by this one, you will get 3.4657, and the 3 significant figures, or 2 significant figures, it's only 3.47 or 3.5 seconds. So it takes 3.5 seconds علشان الكونسنتريشن بتاعي يقل النص في السبستانس دي. تاني اهم حاجه خالص خالص، ما قاليش اي حاجه عن الاوردر، انا عرفت لوحدي من كلمه الديكومبوزيشن that he is talking about a first order reaction. عمال بتعيدها وتزيدها ليه يا مستر؟ I'm just repeating it because as easy as it is most of the students will just miss it in the exam. طيب بعد كده شويه اسئله بسيطه. write the half life. This is direct questions. write the half life and the expression for the K. Okay, this question is telling me the half-life of chromium 55. Chromium 55 is a radioactive substance, and he said that the delivery of a sample of this isotope from the reactor to a certain laboratory requires 14 ساعة. مستر أنا محتاج علشان أشيل الايزوتوب الراديو اكتيف دوت من المفاعل from the reactor علشان أوديه لللاب بتاعي، للمعمل بتاعي، هاخد في الطريق وقت قد ايه يا ياسين؟ I will take 14 hours. انت فاكر الموضوع بالسهوله ديت؟ if you are not calculating it very well ممكن يحصل ايه يا عبد الله قبل ما اوصل؟ السبستانس بتاعتي it might disappear. انا خدت السبستانس من المفاعل من الرياكتور ووديتها لللاب، عمال يعدي عليها تي هاف تي هاف تي هاف تي هاف، وفجاه اهو عبال ما اوصل بيها لللاب الاقيها الاقيها ايه؟ الاقيها اختفت، اتحولت لزيرو. ايه اللي حصل لها يا مستر؟ ديكومبوز 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 ديكومبوز. بيقول لي about what mass of such material should be shipped in order that 1 ملغ is delivered. طب انا عايز ادي له ماس قد ايه؟ عايز ابدا بقد ايه ماس علشان لما اوصل لللاب الاقي باقي عندي 1 ملغ بس. ايه ده يا مستر؟ يعني لو بعد كمان هاف لايف هيحصل لها ايه؟ هتتحول لنص وبعدين ربع وبعدين تختفي. فانت عايز تبدا بكام؟ عايز تبدا بكام ملغ علشان توصل لل1 ملغ؟ في طريقتين الحل. اما ان انا اجيبها بالنمبر، اقول له انيشيالي انت عايز توصل للكونسنتريشن يبقى 1 ملغ، عايز تبدا بكام علشان يبقى عدى عليك الهاف لايفز ديت. طب تعالى نبص كده. انا ممكن احسبها بالمخ كده. انت عايز 1 ملغ صح؟ انت عايز 1 ملغ توصل له. طيب قبل ما يعدي هاف لايف واحد هتكون كانت 2 صح؟ يبقى انت بتعمل مالتبلاي باي 2، وهاف لايف تاني 4، وهاف لايف تاني 8، وهاف لايف تاني 16، وهاف لايف تاني 32، وهاف لايف تاني 64. انت اشمعنى جبت الرقم دوت؟ ما انت بص، عندك كام هاف لايف؟ ادي واحد عدى ساعتين، ساعتين 4، 6 and then 8، بعدين 10، بعدين 12، بعدين 14، بعدين 14. مستر انت لو عدى عليك 4 هاف 7 هاف لايفز 1 2 3 4 5 6 7، السبستانس بتاعتك هتكون عدى عليها 7 هاف لايفز. يعني 7 ملتبلايد باي 2، خد بالك مدي لك 2، 7 ملتبلايد باي 2 يعني عدى عليك ال 14 ساعه دول. عدى عليك ال 14 ساعه اللي انت خدتهم في الطريق. يبقى تاني، if you started if you passed 14 hours means you passed how many half lives؟ 14 divided by 2 يعني 7 half lives. تاني ياسين، انت عدى عليك وقت قد ايه؟ 14 اور، والكل هاف لايف ب 2، كل هاف لايف ب 2 يعني يعدي عليك كام هاف لايف؟ 7. طب انت عايز تنتهي على الاقل 1، ادي 1 هاف لايف، ادي 2 3 4 5 6 7. طب الاخراني كان كام؟ 1 قبليه 2 4 8 16 32 64 128. يبقى انت لو بدأت ب 128 ملغ وعدى عليك 1 هاف لايف 2 3 4 5 6 7 يعني 14 اورز، هتنتهي ب 1 ملغ بس بعد ال 14 ساعه ما يعدوا. after 14 hours have passed. طب انا مثلا مش عايز احسب الحكايه ديت في دماغي كده، خلاص قول له ال 1 ملغ بيساوي A 0 1 اوفر هاف. الانتي لوج بتاعي هيطلع كام؟ الانتي لوج هيطلع عندي 7. so you passed 7 half lives. اعملها بقى مانيوال. 7 1 2 3 4 5 6 7 يطلع لك التايم الكونسنتريشن 128. Okay, we'll continue next time إن شاء الله. We'll have the last part أو the last session of the kinetics of the kinetics, which will be talking about the reaction mechanism and the relation between the kinetics and the thermodynamics. It's going to be also an important session, the last session next time for the kinetics, inshallah. Okay, thank you so much and see you next time, inshallah.